Hello, I hope this chapter is going well for you. This is going to be our last podcast of this chapter, and the rest of it we'll be doing together in class. So what we're going to talk about today is to get you ready for homework 4, and we're going to talk more about that covalent bonding, so how they are sharing their electrons. So you can see in a single covalent bond that I have two atoms. Again, if it's covalent, they have to be two nonmetals, share a pair of electrons. And if it's a weaker bond, they only share one pair. And so what that means, if I take a look at hydrogen, so I want you to have your periodic chart in front of you, and you guys can see that I have two hydrogen in my formula, and look at what family hydrogen is in, or how many valence electrons it has. So hydrogen has one valence electron. So I have two hydrogen, one valence electron. So that means in my total structure that I need to show two electrons. Well, the only way to show that is to draw the hydrogen, draw the other hydrogen, and I would have my bond in between. And so that's my drawing. That's a single covalent bond. So again, if I have a stick, this means that I am sharing two electrons. Now, except for the small ones like hydrogen, they want to obey the octet rule. And remember, the octet rule, I know you studied a lot of this in some prior classes, is they want to have 8 electrons. And we talked about that a lot, how hitting our home run is by getting to noble gas configuration because they have 8 electrons around the outside. So you're going to hear me keep counting and counting and counting with 8. So if I take a look at my double covalent bond, they are sharing 2 pairs of electrons. So how do I see this and how do I figure it out? So if I take a look at oxygen, I have 2 oxygen and they each have 6 valence electrons. So I have a total of 12 electrons that I need to draw in my structure. So if I go ahead and try to figure this out, I'm going to see that I have oxygen bonded to oxygen because that's the only way I can do my structure. Well, then what I like to do is I like to satisfy octet. So if I count this out, I have 2 right here, 2, sorry, and then 4, 6, and 8. And then again, I have 2 on this oxygen, 4, 6, and 8. Now go around and count the total number of electrons that you have. So I'm going to kind of mark this up so you can see what I'm doing here. So I have 2, 4, 6, 8, 10, 12, 14 electrons. Okay, that's too many because here I said that I only have 12 electrons that I can do. So what that means, or that I can use, that I have to have one double bond somewhere. So that means I need an extra bond because then that will take away those 2 electrons. Well, where's the only place I can put that extra bond is right in the middle of the oxygen. So now when I count this out, each bond represents 2 electrons. So right now I have 2 with this one and 2 with this one. So 2, 4 electrons, 6, 8. Then 2, 4, 6, 8 for that other oxygen. And so now I'm satisfied. I have a total of 2, 4, 6, 8, 10, 12 total electrons around the outside, and each of them are satisfied because they have 8 electrons. So let's try this one more time. Let's try it with a triple bond. So now I'm going to try it with 2 nitrogen atoms. So I do the same thing. Do my atom inventory. I have 2 nitrogen. Nitrogen has 5 valence electrons, so I have 10 electrons. So if I do my little trick again, put my nitrogen together, I know that represents 2, 4, 6, 8. Here's 2 again, 4, 6, and 8. Go around and count the total number of electrons that you have in your drawing. So let me mark it up again so you can see what I'm doing. 2, 4, 6, 8, 10, 12, 14 electrons. Well, if I only have 10 available to me, that means I need 2 double bonds. I need 2 more bonds. So those 2 more bonds, where is the only place that they can go? Well, my structure is pretty simple, so here's my original. If I have 2 more bonds, they only can go in between the nitrogen. And now, if I show you how I'm going to count this, this would be 2, 4, 6, 8, 2, 4, 6, 8. And I have a total of 10 electrons. And so this is how we're going to start drawing these bond skeletons as a way to represent these, and this is homework 4. So we'll do a couple more examples here. Now, one thing I want you guys to understand is that I have that single bond and I had one pair of sharing electrons. And then I have my double bond and they're going to overlap even more. And then if I have my triple bond, they're going to overlap even more. So this should make sense to you that this is going to be the strongest bond between them. And this is going to be the weakest, as I started out talking about. Because the more overlapping there is, the more strength that there's going to be in the molecule. So if you're taking a look at homework 4, you're going to see that the structures aren't quite as easy as the 3 that I just showed you. So if I take a look at CCl4, which is carbon tetrachloride, you can see that I need to do my atom inventory. So I have 1 carbon and I have 4 valence electrons, plus I have 4 chlorine, and chlorine has 7 valence electrons. So do the magical math there, and I get 32 electrons. Now, most of the time, the first element that is stated is going to be your central atom. And that probably should make sense to you that I have my C in the middle and I have 4 chlorine around the outside. Something like that. Okay, so right now I hope you're saying to yourself that I've already used 2, 4, 6, 8 electrons. Now, if I take a look at one of the chlorines, I have 2, 4, 6, 8 electrons there. Well, 8 times 4, I have 32. So that works. So I'm just going to go ahead and put 6 more electrons around each one, because then I have satisfied my molecule. And I'm done. So that's my skeleton. We're going to take this from here and we're going to give it some dimension, but we're going to wait to do that until next week. Okay, let's try one more. So we have PBr3, so phosphorus tribromide. So again, I have 1 phosphorus. Phosphorus has 5 valence electrons. I have 3 bromine with 7 valence electrons. And when I add those all up, I get 26 electrons. Okay, so I'm going to use my first one again as my central atom. So I'll have phosphorus in the middle with 3 bromine attached. And if I count up that 1 bromine, I have 2 around it already. So I'm going to add 2 and then 4, 6, and 8. 8 times 3 is 24. So it looks like I have enough to satisfy all of the bromine. Now I only have 24 electrons drawn. So where do you think the other 2 go? Well, hopefully you're thinking on the central atom, because phosphorus right now only has 2, 4, 6 around it, 7, 8. And so now that's satisfied. It has 26 electrons, and I have my skeletal model here that I'll be able to work on VSEPR next. Okay, so I'd like you to go to homework 4, and I think you can do the first part up here, but then down here it tells you that using your VSEPR gold sheet, draw the following molecules. Add up the required electrons, draw the bond sketch, and show all lone pair of electrons. You really don't need your VSEPR sheet for this part, so you can do that without it. So if I take a look at silicon, you can see that silicon, there's 1 silicon and it has 4 valence electrons. And I have 4 iodine with 7 valence electrons. So if I add that all up, I get that nice magic number of, 32. And so if I have 32, I'm just going to draw, I like when I have that 32 electrons with 4 things around it. So my sketch is going to be silicon in the middle. I have 4 iodines around the outside. And it looks like each iodine is going to need 6 more electrons to be satisfied. So 2, 4, 6, 8. 8 times 4 is going to be 32. So I like when I get nice, easy ones like that. Okay, so that's our bond sketch. That's where we need to start. So the first thing you need to do is you need to figure out the number of electrons, figure out your central atom, and try to satisfy them using the octet rule. And we'll continue to build on there, but that's where we need to start. All right, you guys have a wonderful night, and I will see you soon.